Hello everybody, welcome to part 2 of this video about the 1.6 applications of radical functions notes for this college algebra. I want to probably not make this video too long, but I want to take a look just at one of these examples down here that's on these lecture notes. I'm not going to do all of the examples because so many of them are just similar to one another, but I would like to take the time to just look at this number 7 over here because it has quite a few things that are happening to the D over here that maybe I can help elucidate some of the things I was saying in the last video about doing the opposite operations in the opposite order and stuff like that. I'll just explain what I mean. But what we have is that, let's see, it says this function s of d equals 7/2 square root of 2d can be used to approximate the speed in miles per hour of a car that has skid marks of length d in feet. How far will a car skid at 50 miles per hour? It wants to know. So how far the car skids, of course this is the s value, and then we're trying to solve for d. So what we can take a look at is the fact that over here we have such an expression as this. I'm just going to write it there. 7/2 square root of 2d. And so if we think about what operations, when we're just thinking in terms of the PEMDAS, which operations are being done to d, we can just start listing them. So in order, of course, I'll write it again like PEMDAS. I hope that everybody can remember which ones these stand for, but P, it's not even really an operation, this parentheses, but it's still called order of operations. And then this one goes exponents, so I will write an exponent this way, and then this one goes times, divided by, adding and subtracting. And so the operations that are being done to D, in this order, we have to kind of think about this square root almost as parentheses. I'm going to rewrite this one as such. I'm going to call it actually 7/2, and then I'm going to put parentheses over here 2d, and then it goes to 1/2 power. This is the same thing. These expressions are exactly with the same meaning, so I even will say equals. These two things are equal to each other. And when we have this one, it's more clear what we're supposed to do because this 2d over here is inside of these parentheses. You know, the square root is being applied to both of them equally. And so inside we actually have a multiplication, 2 times d. And so the first operation that we have is the one that goes times 2. d is being multiplied times 2. And then we have a square root. So next we have an exponent, which is square root. And then we have another operation, which is that after you multiply times 2 and then after you raise to 1/2 power, which is the same as take square root, we want to multiply times 7/2. And so whenever we're trying to solve for d in this case, because it says that s should be 50, so I'm just going to put that one here, that it should go 50 equals 7/2 square root of 2d. And then we're solving for d. We need to do on both sides of this equation, because that's how we always solve equations. We do the same thing on both sides. We need to do the opposite operations. And so I'm going to write opposite operations. And then we should also do in the opposite order. And so what that means is that the first thing that we should do is we need to undo this operation that's being done, the one that goes times 7/2. We want to, I want my highlighter bigger. The opposite operation of times 7/2 would be, which one? We can do divided by 7/2. Or else, I don't ever like to think about divided by 7/2 because dividing by fractions to me is very annoying to do it. What you can also do in order to undo a multiplication by a fraction is to multiply times the reciprocal. And so divided by 7/2, it's the same thing as times the reciprocal of 7/2, which is 2/7. We can either divide both sides by 7/2, or we can multiply both sides by 2/7. And actually, if you remember about leave, change, flip, or however you learned about dividing fractions, these accomplish the same thing. And so we will do this first. I'm going to actually choose this one, times 2/7. And so I'll just list them and then we'll actually do them. And then we need to undo the second operation, which is the square root. And the way that you undo the square root is that you will, instead of taking square root, you will square both sides. We need to raise both sides to the second power. This will undo this one, which is the same thing as both sides to 1/2 power. If we raise to the second power, it will undo raising to 1/2 power. And then the last one over here, we have to undo the operation that goes times 2, and we would do that by going divided by 2. Which, just to be consistent with the first one, that would be the same thing as multiplying both sides times 1/2. These are the same, but I'm going to go with this one because this is my problem that I'm doing, and so I get to choose to do it this way. If you like to do it some other ways, then I hope that you'll do it and it will make more sense to you to do it the way that you like. But why don't we actually do what we said we would do here? We need to multiply both sides by 2/7. And so we're going to do it on this side, times 2/7. And you see the times 2 and divided by 2, they will cancel. The 7 and the 7, they will cancel. Or else we can just think of canceling the 7/2 and the 2/7 right away, because when you multiply those together, you get 1. And so we will have over here, I'm going to rewrite this one just because I want to do it all in one step with no calculator stuff. This whole thing, I'm going to multiply the 50 times the 2 and get 100, and then go over 7. Because remember, 50, it's like 50 over 1. And so the 50 goes times the 2, you multiply the tops, and you multiply the bottom. 7 times 1, 7 times 1, it stays as 7. And so this thing equals, all we have left is square root of 2d. And then what we said we would do next is we would like to square both sides. So why don't we do it? We'll square them. And whenever we square this one, the square root and the square, they would just cancel. And so I'm going to come over here onto this side. It's going to go 100 squared on top. Do you know what 100 squared is? It should have, instead of 2 zeros, it should have 4 zeros. This becomes the number 10,000. And it will go over 49. Because remember, we have to apply the square to both parts of the fraction. It goes 100 squared and also 7 squared. And then this thing is going to equal just 2d. And then last but not least, we're doing this one. We need to divide both sides by 2. Wow, you know what's happening? I'm changing my mind. I want to actually multiply times 1/2 because doing a fraction divided by 2, all of a sudden it didn't look very fun to me. So I would rather do it this way, multiply fractions times each other. So here the 1/2 and the 2 will cancel. We will get that d is, here the 1 just goes times 10,000. It will still be 10,000. And then 2 times 49 is 98. So if we divide these, it's going to be something like, do you see what it's going to be? This number on bottom is almost 100. That's why I'm going to say it's almost the same thing as 10,000 over 100, which is, the zeros will just cancel, becomes 100. It's approximately equal to 100 feet. So that does it for this example and this video. Thank you guys for checking out this other example, and we will get started on some other sections. Thanks, bye.